This is a very easy question if you know how to solve it using a strategic thinking. So for me, it's very obvious to know what to do here. I clearly have equations, and I know that my favorite SAT strategy is to plug points into equations, okay? There's lots of places where we can use it, and here I get that it's not obvious, right? The equations part maybe is, but where am I going to get points from? Well, sometimes a story in its own way is kind of telling you points, and so you have to be able to pull the points out of the story so you can just plug them into the equations and test what's going on. So the easiest point to pick out in most cases is going to be your y-intercept, what happens when x is 0. So in this case, t years after 2000, well, that's just the year 2000 would be 0. So what happens in 2000? Well, they tell us that there are 30,000 trees, and since the model is talking about trees in tens of thousands, the point would just be 0.30. And hopefully you can realize that just by looking at the y-intercept of all of these linear equations, right? It's 30 in each case. So this point is important in lots of other contexts, but here it doesn't really help us with the answer choices. Instead, we're going to focus on the other point. What else do they tell us? That there are 22,000 trees in 2009. So my t or x value is 9, and 22,000 is going to be the y coordinate, or f of t. Now, if I plug that into these equations, we will see that only one gives us the right answer. So if we did, let's just say choice A and B, both are going to have the same problem where it's a positive value. So we would get, let's just do choice B because it's easier. If we plugged 9 in here for t, just right over it, the 9s will cancel and we'll get 38. So this is an increase, and hopefully, even if you had no idea that the plug points into equation strategy worked here, you'd still be able to think that we need some sort of decrease and negative slope to represent that. So I'll save you the time for choice A and just go on to C and D, which both have decreases. Now again, let's plug the point in. If I plug it into C, it's very convenient because 9 over 1 times 8 over 9 means that the 9s are going to cancel very simply, and the negative 8 is going to get added to the 30 to get me 22, right? 30 minus 8 is 22. So that's proof that the point that I expected works in this equation, meaning it's probably the right equation. Let's try the same thing with D though. Here we'd have negative 9 over 8 times the 9 plus 30. Well, negative 9 over 8 times 9 does not work out nicely, right? That's negative 81 over 8. Now, I don't know what that is, but it doesn't divide evenly, so no matter what, it's not going to get me a number like 22. So I don't even need the calculator here to know that this number is too messy to be correct. And so maybe you would have been able to figure this out using some other kind of logical, abstract thinking, but I just don't trust that kind of thinking on the SAT, and so whenever I can, if I have equations, I'm looking for points to plug into those equations. Sometimes they're just handed to me, other times I've got to pull them out of a question in some way, and getting good at that skill is really important for avoiding traps on the test because that's how we can prove our logic when the SAT is trying to lure us into a trap.